The relationship between microscopic properties, like numbers of particles, and macroscopic properties, like grams that we can measure, is governed by the mole concept and relative atomic and molecular masses. For this chemical reaction, 2 molecules of hydrogen react with 1 molecule of oxygen to give me 2 molecules of water. But any multiple of that number of molecules would work too, like 2 dozen molecules with 1 dozen molecules to give me 2 dozen molecules of water. And a mole is just a number of particles, 6.02 times 10 to the 23rd particles. So 2 moles and 1 mole should give me 2 moles, just as the 2 molecules and 1 molecule gave me 2 molecules. Now there's another way to look at it. We can use relative masses and talk about the mass relationship for this chemical reaction. 2 grams of hydrogen, 16 grams of oxygen would give me 18 grams of water. The hydrogen and the oxygen have the appropriate ratio to give me the correct number of particles, and I know that because of their relative masses. So a mole of hydrogen would be 2 grams. So here I have a mole. These are in 2 to the 1 though, so I need half a mole of oxygen. A full mole would be 32 grams. Half a mole is 16. That would give me a mole of water, 18 grams. And you can see that the mass is conserved. The mass on this side, 16 grams and 2 grams, gives me 18, and I make 18 grams of water. Mass will always be conserved in these general chemistry kind of reactions. So I understand the relationship between molecules, moles, and mass, and how to use them to predict and calculate the amounts of compounds I need in chemical reactions.